Hi everyone, this is a video on section 6.4, Laws of Logarithms in the grade 12 Advanced Functions course. Your homework is on page 347 in your textbook. And remember that you have a performance assessment coming up tomorrow. In chapter 6, all your assessments, PA tests will be no calculator, so remember that. So in this section, in today's lesson, this is on laws of logarithms, and we will be first talking about the power law. Well, the power of an exponential function, or of powers, is b to the power of m to the power of n. You multiply the exponent, that's b to the power of mn. Now in log, we can write log of m to the power of n base b as n times log m base b. So essentially what's happening here is the exponent of m to the power of n and can be brought to become a multiplier to log m base b. This can be shown using a proof here. If I first let x equals to log m base b, I can write this in exponential form, b to the power of x equals m. Now raise both sides to the power of n, then I have b to the power of x times n equals to m to the power of n. What if I write this as a logarithm now? Well, the left side will look like log of m to the power of n base b, right? So log of the other side, base b, is equal to the exponent x times n. But earlier we have defined x to be log m base b. So what does it look like now? It looks like this n can be multiplied to log m base b, and this is exactly the same as log m to the power of n base b. This comes in handy when we need to evaluate log expressions. So if I want to evaluate log 25 to the power of 7 base 5, I can first use that 7, take it to the side, bring it down. So 7 log 25 base 5. It's a lot easier to evaluate log 25 base 5 because 25 can be written as 5 squared. Log of that base 5 is 2, and I get 7 times 2, which is 14. So now I have log of the fifth root of 8 base 2. Well, the fifth root of 8 can be written as 8 to the power of 1 over 5. So now 1 over 5 can be written in front of log 8 base 2. 8 is 2 to the power of 3. So now I have 1/5 times 3, which is 3/5 of 3 over 5. Next, we have 6 to the power of t equals to 300. Well, doesn't look like anything can be connected here. So let's try to log both sides of the equation. Another way to do this is just write this as a single log of log 300 base 6 equals to t. That works too. So if I log both sides though, then I can say, well, t is an exponent of 6 here, so I can write this as t times log 6, and the other side is just log 300. You can write it as log 300 over log 6, and t can be written as log 300 base 6. Which actually takes us to the next identity. In the past, when older scientific calculators are not as powerful, the only log that they can handle is the common log of base 10. So in order for calculators or to use calculators to evaluate any log, like log of any base, we can actually write the log using a change of base formula, which essentially looks like log m, which is what you're doing, and then divide that by log of base b. Because log of base b is in the denominator, and b is the base of a power. Remember, b needs to be greater than 0. It cannot be 1, and m has to be greater than 0. We can log a negative number. So the proof of this is that we can actually set a to equal to the left side, which is log m base b. Now, if I log both sides of the expression, I can, after I arrange it into exponential form actually. So b to the power of a is equal to m, then log that. Using the power rule, a can be written outside. So I have a log b equals to log m. A now can be written as log m over log b. And a originally is just the left side of the change of base formula. So this shows that the change of base formula actually works. And if I need to evaluate using the change of base formula, log 9 base 2, I can write log 9 over log 2 and then punch that into the calculator. Log 2000 base 5 is log 2000 over log 5. Punch that into the calculator, I get 4.72. Log 3 to the power of x equals to 5. Then first I can put that x in front of log 3. So x times log 3 equals to 5. And then I can say, well, x is technically 5 over log 3 to be exact. Or evaluating using the calculator, you get 10.5 roughly. And that's basically the two formulas. Well, just like a lot of the different formulas, identities, the best way to learn it and to master it is through practice. And when you're practicing doing your homework, other than evaluating the actual values of these change of base, you should be doing your homework without the calculator. Okay, see you next time.